Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. If I could click on it, yeah, just like you could click on the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It seems like we're getting another good problem. So how's everyone doing? Hope everyone's having a great week. It's Friday. It is very rainy here in New York, and I stubbed my toe running. So I don't know, I had to figure out how to tie my shoe up, which is a really silly thing to say, but it is what it is. I also watched Deadpool today, the new Deadpool movie. If you saw the Deadpool movie, let me know what you think about that movie. I thought it was fun. It was enjoyable. Was it a good movie? Probably not. I mean, it was like good in the enjoyment, but like I don't know. But that's all you can ask for, right? No one is expecting like a masterpiece, but it was fun and a lot of nostalgia, which as the people who knows that I'm a little bit older, it brings me back. Yeah. Especially like the Bye 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 song. Anyway, okay, let's take a look at today's problem. 840 magic squares in a grid. A 3x3 magic squares is a 3x3 grid filled with distinct numbers from 1 to 9. Okay, given a row column grid of integers, how many 3x3 can... Okay. Grid may contain numbers up to 15. Okay, that's a little bit awkward, but fine. Right, yeah, it's only 10 by 10, so there are a couple of ways you can do this, right? Since it's only 10 by 10, I would advocate in general, just do the silliest, naivest thing you can do. Another thing that you can do is, the naivest thing you can do is just try every 3x3 square, right? Nothing to it, it is what it sounds like. Which is what I'm going to end up doing because I'm lazy today. I'm a little bit tired. It's a little bit later in the day, or in the night. The other thing that you can do, of course, there are two kind of ideas to play with. Not going to give you more guidance on that, other than the idea. One of them is, you can kind of think about it as a sliding window, right? So as you kind of move from left to right, you can remove things that are on the window that you're looking at, and then maybe you could even do like you could travel like in a Hilbert square or something like this. I don't know. There are a lot, or Hilbert curve, sorry. There are a lot of ways you can kind of play around with this to probably get a performance, and it's probably fun. Is it a big deal? For 3x3, probably it's not a big deal, honestly, so it's not that much of an interest. The other thing that you can do is realize that, you're basically doing a convolution, right? And with a convolution, that means that you can probably come up with a fast Fourier transform way of doing it, or discrete Fourier transform, but we're not gonna go over that. That's just an idea. I don't even know how to do that, honestly, but I know that and maybe I'm wrong on this one, so let me know in the comments if I'm wrong. But my understanding is that you probably can, especially for this one where you're just trying to get rid of 9 numbers, but I could be wrong. It's not really a big deal. But yeah, so let's just do it naively. Given these constraints, naive will be fast enough. And the other thing that I would say is that, if you see a problem like this and you're like, oh, I know how to do this immediately. There are two things you can do, right? One is, why is this a little bit big? Okay, yeah, one is up south by doing harder things to solve this problem, just to kind of learn and practice, right? The second thing that you can do is, why is there something downwards? Maybe there's something funky about this one. I don't know. But the second thing that you can do is just try to solve this as fast as possible. You should be able to be fluent or well practiced enough that you should be able to do this in just fast enough time, right? So that's the idea. And then now let's play around with this one, and maybe I would try to do it I wouldn't say as fast as I can, just because I'm talking, right? But I think that should be good enough, right? So for x in range of r minus 2, right? For y in range of r minus 2, oh sorry, c minus 2, of course. Right, maybe we have a scene is equal to set, and then we have a dx in range of 2. For dy in range of 2, and then we have so we have current is equal to grid of x plus dx, y plus dy. If current is between 1 and 9, which we have to worry about. Then scene, we add current, and of course this handles the dupes anyway, because then now at the end you can say if length of scene is equal to 9, then we increment count, and that should be good. Unless I misread the problem, and honestly I'm like relatively confident about this one. My only for now, my only like weirdness or the thing that raises my doubt is that there are a lot of downvotes for some reason, so I'm not really understanding this. Maybe if I get a wrong answer and it'll show me. Okay, that doesn't seem likely for this one, so I probably just have a mistake, right? X plus dx, y plus dy. Am I missing y? C is equal to 2, so C is 3, so that's 0 and 1. No, that should be fine. Why am I why is this wrong? Yeah, some days you're just like really bad. 0, 0 is 4. That's definitely not. Oh, I'm dumb. This is 2, but it should be like from 0, 1, and 2. Okay, that is just a Larry finds a way to screw it up kind of thing. But that said, it's still wrong for some reason. So let's take a look. 0, 1. Yeah. Wait, why is this one not? Maybe I misread this, huh? Oh, it has the same sum. I'm sorry, I misread. I didn't. For some reason, I just thought it needed to contain 1 to 9, not the both diagonals have the same sum. Okay, so I mean, still, most of the things I've said probably is still true, but you know, yeah. I mean, obviously, we have to kind of change how I implement this. You still should try to time trial this as much as you can. But yeah, so okay, so we have this, and this is one of the conditions, and then now maybe yeah, okay, then now you could do this in a number of ways maybe, but each distance. I mean, this can only be true if it is 15, right? Like, I don't think you can. Yeah. So, I mean, from that already, you can already do some filtering now that we have additional rules, right? I just kind of, for some reason, I didn't read it correctly. I am very, I don't know. Maybe I'm just tired. Maybe I'm just sloppy. I don't know. But the point is that now that, you know, I read it maybe correctly, hopefully, the middle number has to be 5. So already you can maybe play around with this, with some filter to make it slightly faster. Like if grid of x plus 1, y plus 1 is not equal to 5, then we continue, just because there's no way to do it, I think. Oh wait, no, yeah, 1 to 9. Okay, no, because I'm just trying to, because it could also go up to 15, so I was like, is there a way so that they have to be the same but not? I don't know, right? Anyway, yeah, so then now we can maybe do like for each row, right? Row is equal to 0, row is equal to grid x plus dx, y plus dy. If row is not equal to 15, then good is equal to 4, something like this, right? Maybe this is very awkward. I think the cleaner way of doing it is, of course, having a helper function. So maybe let's do that. Definitely good if xy, and this is like the upper left corner. Right, so then now we can just put all these in here, right? This was getting a little bit long. So yeah, so if good of xy, we add a count. We could even put this in there, really. Doesn't. Right, and now we can do an early return false. Right, yeah. And I guess we can also just put this earlier, right? So if scene is yeah. Oh, if this is not equal to 9, then we just return false. And then now we don't even need this good anymore, right? We just do this, return false. I'm a little bit, yeah. Maybe you can yeah, write this in a slightly cleaner way, but honestly, I'm a little bit tired. Oh no, so dumb. So yeah, this is probably like colors and code sum. Yeah. And then we have to do the diagonals, which is a little bit more awkward, maybe. Right, so for maybe diagonal 1 is equal to 0, right? For D in range of 3, if diagonal 1, we add grid of x plus D, y plus D, right? So we have do, right? And then you can also even just do the other one here as well, and you add grid of what is it? X plus 3 minus D maybe, or 2? Is it 2 minus D or 3 minus D? But some we only have to change one of them to get the other diagonal, right? So yeah, so the other is going to be 2, is going to be 0, so it should be 2 minus D, or you know, should be 3 minus D plus 1 kind of thing, as in like n minus 3 plus 1. But then yeah, if diagonal 1 is not 15 or diagonal 2 is not 15, then we return false. We're going to return true. And I think now we should are good, at least given that we understood it. Still don't understand why so many downloads. I mean, I don't think this is that bad. Let me submit it before it's the first time I've done this apparently, but yeah. I don't think this is that bad. 92 day streak, that's kind of nice. But yeah, I don't think that was this bad. It was just me not reading the problem and try to rush it a little bit. So that's the thing with time trial, is that obviously you have to read it correctly first. But yeah, yeah, and there are some magic constants here, like 15, but that's just the way how magic squares work on, at least on a 3 by 3 magic square. You can kind of do some proof for every n, at least for n by n grids of n square numbers, and then you can do some maths. I think it's actually fascinating. We haven't done it before. It's kind of fun if you're a nerd anyway, like me. Yeah, I think that's all I have for this one. Yeah, I don't really have much to say. I mean, I'm just gonna let's take a look at the solution. Maybe, I guess manual scan. Okay, I guess that's what I did, right? Oh yeah, the complexity. The complexity, given that it is all times c, we just do 9 operations here, 9 here, 9 here every time. So this is going to be all of all times c, or linear time, because that's the size of the input. Yeah. Yeah. Oh, guys. So manual scan. Okay, that's what we did. Check unique properties of the. It has to have the same sum. Okay, because we can say that. Oh, okay. So I guess, yeah, you can. Yeah, I mean, I did the check the middle element part because I that's just obvious. But I guess you can also, like, there's only. I guess all variation is going to be just a variation of this, except for just like the rotation, right? So that and then the flip of it. So in theory, there's at most like what, 16 different, and probably less because some of them are dupes. Probably, I don't know if that's true. But either way, like up to 16 different magic squares, and you can, I guess, like put them in a hash map and then just do a rolling hash or something like this. I guess you could do something funky like that and it'll be fine. Yeah. I don't know. Yeah. I don't know why. I mean, yeah, I guess so. Fine. Yeah. I mean, you could definitely do more optimizations. I don't know if it's that interesting. But yeah, this is all I have for this one. Let me show you the good code. And I don't mean that the code is good. It's just what I name my function. Here's the. I mean, this is just pretty straightforward. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.